Okay, part 2 of ionic compounds and loading the screen. So this is the screen we were looking at the one before. We were talking about how those opposite charges attract, and then that forms a bond between those two elements. So sodium and chlorine, they come together. And so this was to put dots on the dot diagram, and then to show how they move over, and then how chlorine would be full, and then how those opposite charges would attract. We can move on. Okay, so here are as a little maze, and you are supposed to connect the two elements together and show which ones would make a bond. And so that's a little exercise that you can do on your own. So now, how are chemical formulas written? Okay, so we have to think about when elements have those valence, those cation numbers, and what's the appropriate ratio. We've been talking about that. So first off, a chemical formula is a group of symbols that show the ratio of elements in the compound. You know, the recipe, we've been talking about that. So the example they give us is MgCl2. Now a number that's written lower here, that's a subscript, and that tells us how many chlorines have to be paired up with the other element. And if there's no subscript, tells us there's only one of that element. If there's no number, it's one. It's understood. Okay? So to write a formula for ionic compound, write the symbol of the positive ion first, then the symbol of the negative ion. Add the subscripts that are needed to balance the charges. So in the example given down here of the coral reef, the calcium carbonate, the formula for the compounds of the polyatomic ions are written in a similar way. Calcium carbonate has a formula of CaCO3. There is one calcium, and it's got a +2 charge, so a +2 would go here, and then the -2. So it's a 1-to-1 ratio, so we just have one of each. We don't write the twos cancel out when they're the same. So now, for ionic compounds, the name of the positive ion is written first, and then the negative ion is written second. Now, the rule is that if it's a single element by itself, that's the negative ion. If it's a single element like chlorine here, we drop the ending of the element's name and we add IDE. So magnesium chloride. See how we changed the N from chlorine to chloride? Okay, so the same way here with sodium bromide. So this tells us that it's Na and Br. And you'd have to look up the ions on the charts on the previous slides. If it's a polyatomic, like this one here is a nitrogen oxygen here, so we drop the ending if it's a polyatomic one, and we make the ending an ATE. ATE. So we're going to go over that stuff, or we did on Monday, and we'll see if we can't get that straight in your noggin. Okay. So properties of ionic compounds: they are hard, brittle crystals that have high melting points, and they conduct electric current when dissolved in water or melted. So this is where we talk about our crystalline structures. Our solol, it was an ionic compound, phenyl silicate. Okay. So, and then there's some questions. They have high melting points and high boiling points and conduct electricity. There's a little link there of a pickle. You can see that the salt water that it's pickled in will conduct electricity. Okay, good luck with those questions. Email me if you have questions.